Learning objectives. In this lesson, you would be learning about quality assurance and standards and the following in detail. Handling of advanced electronics equipment. Introduction. This section has requirements to ensure that products are controlled properly. They are achieved through all phases of handling, storage, packaging, preservation and delivery. These measures will ensure that damage or deterioration of the product is prevented. Documented procedures ensure that the product remains undamaged. They will not suffer deterioration. Raw materials must be secured and segregated in storage from finished materials. There needs to be documented procedures for transfer of materials. Formal and documented packaging procedures, marking requirements, and instructions must be under controlled systems. And of course, personnel must be trained. The delivery of the product must be in accordance with the contract. The supplier is responsible for getting the electronic product to the consumer. It may be commercial or defense in the condition. It will work to specify requirements. Again, these are documented, auditable, and established processes with specification and standards. It applies to all processes: business, support, and product hardware, software, and services. Internal procedures, including flowcharts, should be generated for this area. Each company should have standard practices that all employees use. Consumer products are a good example. Items like a television or home appliances have lots of packaging and plastic over areas. Electronic equipments. Let us see how to handle the following electronic equipments: laptop, multimeter, oscilloscope, fingerprint reader, industrial motor drive, quadcopter. Laptop. A laptop can effectively be turned into a desktop computer, a hardware frame that supplies connections for peripheral input or output devices such as a printer or a larger monitor. Laptops usually come with displays that use thin screen technology. The thin film transistor or active matrix screen is brighter and views better at different angles. Safety measures. Ideally, keep the computer in a clean and dust-free room. Keep food away from your laptop. Be sure to plug accessory devices into their proper slots. Handle any removable drives with care. Insert drives into their slots carefully and at the correct angle. Try to keep the laptop on a flat, clean surface. Don't use your laptop on the bed. Use an old toothbrush to clean the area around the exhaust fan screen. Avoid placing heavy materials such as books on top of your laptop. Multimeter. A multimeter or a multi-tester is an electronic measuring instrument that combines several measurement functions in one unit. A typical multimeter would include basic features such as the ability to measure voltage, current, and resistance. Analog multimeters use a microammeter whose pointer moves over a scale calibrated for all the different measurements that can be made. Digital multimeters display the measured value in numerals and may also display a bar of a length proportional to the quantity being measured. Measuring voltage. To start, let's measure voltage on a AA battery. Plug the black probe into COM and the red probe into MAV ohm. Set the multimeter to 2V in the DC, direct current range. Almost all portable electronics use direct current, not alternating current. Connect the black probe to the battery's ground and the red probe to power or positive. Squeeze the probes with a little pressure against the positive and negative terminals of the AA battery. If you got a fresh battery, you should see around 1.5 V on the display. Measuring resistance. Normal resistors have color codes on them. Pick out a random resistor. Then hold the probes against the resistor legs with the same amount of pressure. The meter will read one of three things: 0.001 or the actual resistor value. In this case, the meter reads 0.97, meaning this resistor has a value of 0.97 k ohm or about 1 k ohm or 1000 ohm. If the multimeter reads 1 or displays OL, it's overloaded. You will need to try a higher mode such as 200 k ohm mode or 2 mega ohm mode. If the multimeter reads 0.00 or nearly 0, then you need to lower the mode to 2k ohm or 200 ohm. Measuring current. Insert the probes into the correct connections. This is required because there may be a number of different connections that can be used. Be sure to get the right connections, as there may be separate connections for very low or very high current ranges. Set switch to the correct measurement type, that is, to measure current, and range for the measurement to be made. The range on the multimeter can be reduced later if necessary. However, by selecting a range that is too high, it prevents the meter being overloaded and any possible damage to the movement of the meter itself. Safety measures. De-energize and discharge the circuit completely before connecting or disconnecting a multimeter. Never apply power to the circuit while measuring resistance with the multimeter. Connect the multimeter in series with the circuit for current measurements and in parallel for voltage measurements. Be certain the multimeter is switched to AC before attempting to measure AC circuits. Always start with the highest voltage or current range. Oscilloscope. An oscilloscope is a laboratory instrument commonly used to display and analyze the waveform of electronic signals. The oldest of oscilloscope, still used in some labs today, is known as the cathode ray oscilloscope. Modern oscilloscopes electronically replicate the action of the CRT using a liquid crystal display. A typical oscilloscope can display alternating current AC or pulsating direct current DC waveforms having a frequency as low as approximately 1 Hz or as high as several megahertz. Before you turn on the CRO on, make sure the intensity control is wound down. Turn the CRO on. Wait for the tube to warm up and start operating. Turn the intensity control up until you have a horizontal line which is not too bright. Adjust the focus control until you have a line which is as thin as you can get it. Connect a probe into the CH1 input. Connect the probe tip into the CAL output. Adjust the time-based control and amplitude control for CH1 until you have a square wave which takes up most of the screen and shows you at least one full cycle. You are now ready to use the oscilloscope to measure all sorts of waveforms. Fingerprint reader. A biometric fingerprint reader creates a high-resolution image of unique patterns of the person's fingers. Once the reader has recorded these patterns, it will ensure accurate recognition of the same person based on his or her unique fingerprints. Sensor. The sensor, which scans the fingerprints, is the most basic and primary part of the system. Processor. Then, there's a processor which stores the fingerprint images in a database. Database. The database is another important component of the device which stores reference numbers, PIN numbers, names, email IDs, employee number, etc. This data helps to match and identify a fingerprint with an individual. Screen and user interface. Depending on the type of device, there may also be a screen on board the device, which will help the users to operate the device via a keyboard on the surface of the device. Software. Of course, there will also be a software sitting inside the machine too. This software's one and only job is to compare and match the fingerprints with the individual's system. Safety measures. After installing the fingerprint reader in your PC, start the fingerprint management program. Place the top of your finger over the reader carefully so that it registers your fingerprint starting from the first knuckle. Press firmly and move your finger over the reader carefully till it completely passes over the reader. Pay attention to the prompts that your computer gives out to see if the reader has registered your fingerprint. Sometimes the program may prompt you to swipe your finger more than once if it failed to capture the fingerprints the first time. You can enroll another fingerprint in the same manner for others to gain access. Motor driver. A motor driver is a little current amplifier. The function of motor drivers is to take a low current control signal and then turn it into a higher current signal that can drive a motor. The most common values of maximum supply voltage are 36 voltage and 52 voltage. We also carry motor drivers with supply voltage up to 450 voltage. The number of outputs can be between 1 and 12, with the most common motor drivers having 1, 2 or 4 outputs. Precautions. Turn on and turn off should be done by operators or inspectors themselves. Internal circuit of the driver kept charged with high voltage for a while even after power off. Turn off the power and allow 15 minutes or longer LED display of the panel has gone off before performing maintenance and inspection. Disconnect all of the connection to the driver when performing the mega test to the driver. Otherwise, it could result in breakdown of the driver. Daily inspection. Main circuit voltage, ambient temperature, humidity, dust, abnormal vibration and noise, loose connection, cleanliness at front portion of the driver and connector. Periodical inspection, loose tightening, trace of overheat, damage of the terminals. Quadcopter. A quadcopter is multi-rotor copter with 4 arms, each of which have a motor and a propeller at their ends. In a quadcopter, 2 of the propellers spin in one direction, clockwise, and the other 2 spin the opposite direction, counterclockwise, and this enables the machine to hover in a stable formation. Before starting, the flight battery and the transmitter battery must be fully charged. Always turn on transmitter first and then quadcopter multirotor. Watch for visible damage such as loose screws, broken, unbalanced or damaged propellers, faulty connectors or solder joints, broken pipes, etc. Perform a pre-flight check. During the flight, improper operation can cause serious injury and property damage. Never fly towards viewers and avoid flying over spectators. Keep in mind that viewers could get close to the quadcopter multirotor without being aware of potential dangers. Always turn off the quadcopter multirotor first and disconnect the flight battery before turning off the transmitter. After the flight, make sure that there is no damage of the propellers. See the handling and safety precautions of LiPos. After a crash, the sensors and electronics might be damaged. Before the next start, everything must be checked. Handling of medical ancillary devices and allied electronic equipments. Let us see handling of some of the medical ancillary devices and electronic equipments. The equipments are blood tubing, transducer protectors, single needle devices, and conductivity meter. There are three guidelines to address this issue. The first two, the Association for the Advancement of Medical Instrumentation, American International, Standard for Hemodialyzer Blood Tubing, RD17, 1984, and the International Organization for Standardization, ISO standard for blood tubing and dialyzer connectors, both are directed to the manufacturers of blood tubing. The third standard is the HCFA Final Rule, Medicare Program, Protocol for the Reuse of Dialysis Blood Lines, 42 CFR Part 405, Federal Register, May 2, 1990. This rule requires that if a facility reuses blood lines, it must reuse only a blood line for which the FDA of that particular blood line. Additionally, the facility must reuse blood lines only in accordance with that protocol. In the absence of any other standards of practice or use for dialysis facilities and personnel, we will discuss proper use and handling. Manufacturer's instructions for use serve as the best standard. Transducer protectors. Manufacturer's instructions for use will serve as the best standard. The Centers for Disease Control and Healthcare Financing Administration stipulate that transducer protectors should not be reused. Single needle control. Single needle control devices are included in the AAMI American National Standards for Hemodialysis Systems as well as in the ISO standard for hemodialysis systems. Manufacturer's instructions for use may serve as the best standard to follow. Independent reference meters. Two standards refer to conductivity reference standards, including the National Institute of Standards and Technology, NIST, and the Organization of Legal Metrology, a European bureau similar to NIST. These standards relate to specific QAS electrolytic conductance. Quality assurance policies and procedures. Policies and procedures concerning ancillary equipment and supplies as they relate to the hemodialysis therapy must be developed. They should be written, implemented, and evaluated. All standards must be incorporated into these policies and procedures. Specifically, the policies and procedures should address purpose and function of each device, its use, maintenance, safety factors, troubleshooting and repair, and related documentation need to be included. The risks involved must be clearly identified and considered, and appropriate safety measures and preventive systems should be developed. Specifically, the procedures must address storage and inventory control, use handling, disposal, complication management, and repair. Staff training and continuing education. Role descriptions should describe all personnel responsibilities for handling and use of ancillary supplies and equipment. The ordering, confirmation of proper labeling, testing and monitoring, and other similar responsibilities should be explained properly. Each responsibility should stem from a specific policy or procedure. Staff training should be a well-defined and organized process. Content should be clearly defined for the learner and based on behavioral objectives. The behavioral objectives can be used to accurately and objectively measure learning. At the end of the sessions, the instructor should confirm by a written test or by written demonstration that learning has occurred and that the learner is able to perform the procedures independently without error. Testing results should be documented and placed in the employee's personnel file. Comprehension of the purpose and function of each piece of equipment or supply requires a basic understanding. It should be of normal physiological concepts as well as responses associated with uremia and hemodialysis therapy. Content should include principles of dialysis, patient response to therapy, and related complications, aseptic technique, and inventory control. The interrelationships of each device and the delivery system, dialysate, dialyzer, etc. must be incorporated into the training process. Need for further education, such as in-service or intensive educational sessions, can be determined from the routine quality assurance monitoring process. The ongoing staff performance appraisal process can be made next stage. When problems are identified, all staff should be made aware of the problem and be involved in its solution. This always includes problem-specific continuing education. Monitoring and evaluation of handling procedure. The medical director of the dialysis facility must authorize. He or she should recognize that the individual has successfully completed the initial education and training program. The medical director is also responsible for assuring that an annual performance evaluation has been performed. To assure patient safety through the proper use of ancillary equipment and supplies as well as test instruments, the following monitoring activities are recommended. Blood tubing, daily monitoring on a per treatment basis. Patient care staff should confirm that the blood lines are compatible with the delivery system and dialyzer. It should ensure that packaging and all caps on the blood tubing sets are intact. It ensures that the manufacturer's intent for a sterile, non-pyogenic, extracorporeal circuit is maintained. Blood tubing. A physical check of all bloodline connectors, dialyzer, accessory ports, heparin syringe, etc. should be confirmed before attachment to the patient and starting the blood pump. Arterial and venous pressure alarms should be appropriately set to detect excess pressures that could cause line separation. A visual inspection of the blood tubing and blood tubing connectors for damage, leaks, and whole or partial occlusions, etc. should be performed. Assure that the 8-form detector is in the proper position and armed. At the time of setup, all connectors and lines should be inspected by the staff member to ensure absence of kinks, partial occlusions, or other physical damage. All connections should be double-checked for secure fitting. Patient monitoring. The following should be part of regular intradialytic monitoring and may be related to malfunction or improper use of blood lines. Acute blood loss, obvious source of blood spill, shock, vomiting, convulsions. That may be the result of extreme pressures in the blood circuit or poor connections, resulting in disconnection of connectors or other leaking from the blood lines. A pyrogen reaction, shaking chills, increase in patient temperature of more than 1 degree Celsius during treatment, or septicemia identified through blood cultures may be the result of an improperly sterilized bloodline. Air embolism, evidence of air in bloodlines and entering patients, chest pain, dyspnea, coughing, cyanosis, visual problems, confusion, coma. That may be the result of the disconnection of specific connectors in the bloodline set or air entering through a damaged component. Other monitoring. An incoming materials log should be maintained. Included in this log should be the identification of the product, delivery date, lot number, and person receiving the products. Confirmation that the product is labeled as ordered should be performed. Any product with labels not intact or incorrectly labeled should not be accepted. An annual review of all policies and procedures related to blood tubing handling should be performed. All incidents or adverse occurrences related to blood tubing should be documented and reported at the monthly quality assurance meetings. Prevention. For prevention, the users have to follow the manufacturer's instruction. Transducer protectors. A daily monitoring. Visually confirm that the packaging and caps are intact before use. Visually confirm that the transducer protector does not contain water or blood at the beginning of treatment and periodically throughout treatment. Assure that the transducer protectors are compatible with specific dialysis delivery systems. Double check that the connections of the transducer protector to the dialysis delivery system and to pressure monitoring tubing of the blood tubing set are secure. Before use, the staff member setting up the system should confirm that the transducer protector does not have occluded ports, cracks, or any other physical damage. Single needle equipment, a daily monitoring. During setup, check that the blood clamp or blood pump occludes tubing and interrupts flow. Confirmation that pressure alarms are set according to the manufacturer's specifications. Calculate the stroke volume at the beginning of the treatment and confirm that the stroke volume fits within the prescription and the manufacturer's recommendations. Monthly monitoring. An annual review of all policies and procedures related to single needle equipment should be performed. All incidents or adverse occurrences related to single needle equipment should be documented and reported at the monthly quality assurance meetings. Prevention. All preventative maintenance required by the manufacturer must be performed to assure ongoing function, patient safety, and treatment effectiveness. Conductivity reference meters. Daily monitoring. Most conductivity meters include a self-test function of electronic circuitry and battery. If the user's meter is equipped with this function, the self-test should be performed before every use. Before using a meter to recalibrate a dialysis delivery system, the conductivity meter should be checked according to manufacturer's instructions with a standard conductivity solution. That conductivity should be entered on a regular conductivity meter log. Manufacturers of some conductivity meters recommend that proper calibration of the meter must be confirmed with standard solution daily. Hemodialysis monitoring. All of the monitoring procedures described above should be performed by the home dialysis patient. It should be supported by home dialysis personnel. Then it should be reviewed by the medical director. Conclusion. Thus, we have learnt about quality assurance and standards and the following in detail. Handling of advanced electronic equipment.